All right. Welcome, everybody, to Standing for Truth. I want to thank everybody for being here for tonight's much anticipated and epic debate. This is the debate you have all been waiting for. We have two very seasoned debaters, Leophilius and Dr. Kent Hovind. And the topic for this much anticipated showdown is Big Bang or modern cosmology versus biblical cosmology. Which model is best supported by the evidence and by reality? Leo and Kent, thank you so much for giving us your time for tonight's important debate.
Thank you.
Thank you.
Awesome. So as we always do here on this channel, though, gentlemen, let's get to know the debaters a little bit before we get into the opening statements. Kent, Leo, again, thank you for being here. Let's break the ice. Let's get to know you guys a bit. Leo, why don't we start with you? A little bit about yourself, who you are, and what people can expect over at your channel.
Yeah, I go by Leophilius on YouTube. People just oftentimes call me Leo. To some people, I'm Leophilius because they can't pronounce my name right. It would also help if I'd actually put it in English. But anyway, yeah, I don't have any degrees or anything like that. I'm just some guy on the internet who really likes physics, astronomy, cosmology, and quantum mechanics. I've been studying the subjects on my own for about 10 years now, watching lectures through MIT, OpenCourseWare, Stanford University, Yale University, Harvard University, reading textbooks on the subject. I'd like to think I have a fair understanding of it, but I am not a professional, and I don't claim to be one. I do science education and science communication on my channel with a focus on astrophysics, cosmology, and quantum mechanics. I do touch on some other subjects, some philosophy, and some politics and things like that. So if those are things you're interested in, regardless of your perspective, whether you have a perspective that agrees with mine and you're looking for somebody that you can listen to, or whether you have a perspective that disagrees with mine and you're looking for somebody to hear a different perspective from, feel free to check out my channel.
Well, I appreciate that introduction, Leo, and thank you for being willing to do this debate. Kent, how you been? A little bit about yourself and what's going on over at Dow.
Well, Kent Hovind, raised in East Peoria, Illinois, in a family of engineers and teachers, and love physics and science and all that kind of stuff also. Ended up becoming a Baptist preacher, but for 15 years I taught science and math in high school and 3 years in college. I love the Bible. I believe it's absolutely true, scientifically accurate. God made everything in 6 days. We started a ministry called Creation Science Evangelism, where we teach the scientific evidence that supports creation. And someone gave us 140 acres up here in Lenox, Alabama, population 35. And we are building a Christian campground and science center that's amazing, 12,000 square feet of science center activities for teaching about the creation of God. And it's all free. Come on down, visit Dinosaur Adventureland in Lenox. Our YouTube channel, Kent Hovind Official, reaches quite a few folks, and our videotapes in 42 languages on creation science evangelism. You can get those on Dr. Dino, my website. I just want to defend the Bible as being scientifically accurate. God made everything. And I think the evolution theory is stupid and dangerous.
Well, I appreciate that opening, that introduction, Kent. I also appreciate your introduction, Leo. This is definitely going to be an epic debate. A couple announcements, reminders. There will be, I imagine, a couple after shows. So anybody who is having an after show for this much anticipated debate, please let me know and I will announce it. Logical, plausible, probable. Thank you so much for the super chat. He says epic after show kicks off 5 minutes after this debate ends. So please.
Can I shout out another after show quickly?
Yeah,
would that be all right?
Ahead,
I just wanted to say that Amy Newman and James W. will also be hosting an after show on their channel. I may or may not be there. It just depends on the plans that I have after the debate.
Perfect. I appreciate that, Leo. I figure, this debate would continue after the debate. This is also the second main event of the week. On Tuesday, we had Matt Slick take on Dr. Shabir Ali. They debated the Trinity. We had a great audience for that. So if you have not yet seen that debate, check it out. And nothing's different for this debate as well. We've got a great audience already. We've got 150 people in the chat, and we haven't even gotten into the opening statement. So that being said, I'm going to go over the format real quick for the audience sake. We're going to be starting off with 12-minute opening statements. Leo's going to start us off with that. Then we're going to have a couple uninterrupted rebuttals. The first rebuttal is going to be 8 minutes. Second rebuttal is going to be 4 minutes. Then we're going to have a short open discussion. We're going to make sure it's equally timed and professional, where the debaters can take turns asking each other questions. Then we'll have a quick 5-minute closing statements, and then that's where we get you guys involved in the audience. We're going to have an audience Q&A, roughly 20 minutes. So please tag me at Standing for Truth with your questions. That way I won't miss them. So enough for me. Let's get right into the debate you all came here to see. Leo, whenever you're ready, do you gentlemen want me to time you guys as well, or do you guys want to time yourselves?
You can time me if you'd like to, but I am going to time myself just so I have a clock that I can look at.
All right, perfect. I'll just put the time just in case. Maybe you guys forget to look at it or something. But ultimately, I'll leave it up to you. So, Leo, whenever you're ready, I do see you're sharing your screen here. So, looks like it's up and good to go.
Is it full screen?
It is. Yes.
Okay, good. I just wanted to make sure when I hit the present that it actually went full screen with StreamYard.
It looks
just
great.
Just let me know when I'm ready to start.
Sure, you can start right now, Leo.
So the subject of tonight's debate is contemporary cosmology or modern cosmology versus biblical cosmology. And the very first caveat that I'd like to provide is that modern cosmology does not tell us anything about the origin of the universe. It doesn't tell us anything about where it came from or what is prior to the earliest moments that we can currently measure. It does not tell us anything about that at all. So if anybody is expecting me to give them answers as to where the universe came from, nobody can, because nobody has those answers. We do not have physical models that can give us that information. The first thing I'd like to start with is the hot Big Bang model. This was the model that was initially proposed by Georges Lemaitre, a Catholic Jesuit priest in the 1920s. The first piece of evidence that we have for there being a hot Big Bang is Einstein's general theory of relativity, which is one of the most well-confirmed and well-substantiated physical theories humans have ever created. What general relativity gives us is an empirically accurate description of the structure and the dynamics of space-time, what it is and how it works, and how mass energy interacts with that space-time to give rise to a force that we all know as gravity. A man by the name of, I believe it's Alexander Friedmann, gave solutions to general relativity's equations that were exact solutions or analytic solutions for those who know their math, which gave us a dynamic space-time, a space-time that could not be static, which means it's neither expanding nor contracting, which is what the initial consensus was. The Friedmann solutions in doing this give the scale factor, which is a measure of the expansion of space-time as a function of the mass energy density of that space-time, and what we get is a space-time which is expanding. Einstein initially introduced something called the cosmological constant, which is a fudge factor into the equations to correct for the initial assumptions drawn from those equations that space-time must be dynamic. He later retracted this and called it the biggest blunder of his career. The second piece of evidence for the hot Big Bang is Hubble's observed galactic redshift. In 1929, Edwin Hubble made an observation that galaxies that are very, very distant from us appear redshifted, and the more red they appear, the further away they are. What this means is that it isn't the galaxies that are moving, it's the space between us and the galaxies that is expanding. And if we can measure that space-time is expanding, we can inverse the functions, and we can sort of contract the universe in a conceptual manner, and providing some corrections for modern observations to the initial derivations, we can end up with an age of roughly 13.78 billion years. The third piece of evidence is the cosmic microwave background, and this is often cited as the most powerful evidence for the hot Big Bang model. Given the model that Lemaitre had proposed and its corroboration by Hubble's observations, what we found is that, well, there should be, or what we thought is that there should be some sort of radiation that permeates all of space-time that's sort of remnant from this very, very dense, very hot region in the universe's history. And in 1965, by complete accident, two physicists by the name of Arno Penzias and Robert Wilson discovered this. And later measurements of what they discovered by numerous satellites that have gone beyond Earth's atmosphere, so we know this isn't the result of any atmospheric scattering, have confirmed that this is indeed the cosmic microwave background radiation remnant from a very, very hot and very dense period very early in the universe's evolution. This provides powerful confirming evidence that the universe originated in a very hot, very, very dense state. And the final piece of evidence for the hot Big Bang is the abundance of hydrogen in the universe. Currently, hydrogen constitutes about 75% of the baryonic mass energy density. Baryons are like things that are made of the normal matter that we're used to seeing. That makes up about 75% of the mass energy density of baryonic matter in the universe. 98% if we throw helium into that mix as well. We don't know of any mechanisms that would be capable of producing such an abundance of very light elements from so early in the universe. But we do know of one, and that is known as primordial nucleosynthesis, which I will touch on a little later. Remaining issues with this hot Big Bang model are known as the flatness problem, the horizon problem, and the magnetic monopole problem. The flatness problem is the problem that the universe appears to be geometrically near perfectly spatially flat, which cannot be explained by the hot Big Bang model. The horizon problem observes that very, very distant regions in space-time that are causally disconnected appear roughly the same temperature. The hot Big Bang model cannot explain why that is the case. The magnetic monopole problem asks why, if magnetic monopoles should have been produced during the exceptionally hot and energetic phases of the Big Bang, do we not observe any? The hot Big Bang model cannot explain why we do not observe magnetic monopoles. And this brings me into the second part of my opening statements: inflationary cosmology. The solution to the flatness problem was originally proposed by Alan Guth in 1981. He proposed this in his paper discussing inflationary cosmology, or inflation as a mechanism for solving these problems. If the inflationary epoch had occurred, we should observe that the universe would be very, very flat, because the inflationary epoch would have stretched it to being near perfectly flat, and it is near perfectly flat, as you can see here. The solution to the horizon problem is found in the fact that if the universe was once very, very small, these causally disconnected regions would have actually been causally connected, and so there's no problem with the fact that they look the same. What inflation did was stretched them after they had looked the same when they were much closer together. The solution to the magnetic monopole problem is found in the fact that inflation would have dispersed these magnetic monopoles so far from any local observer that we wouldn't be able to detect them today, and lo and behold, we don't. So inflation immediately solves all three of the major problems with the Big Bang model. But what about the direct evidence for inflationary theory, the empirical evidence? The upper limit to Big Bang temperatures, as a result of how large space-time would have been at that time and the mass energy density of it, would not have been capable of exceeding roughly 10 to the 19th giga-electron volts, which is just a way that physicists can measure energy. And observations of that cosmic microwave background, or rather the fluctuations in it, that I mentioned earlier, show us that these temperatures during the Big Bang phase didn't exceed 10 to the 16th GeVs, which is below the expected limit, which provides strong observational confirmation of an inflationary epoch. Primordial fluctuations as density perturbations. In this inflating space-time, there would have been fluctuations as a result of uncertainty, and these should transfer to perturbations or fluctuations in the density of the distribution of matter and energy that we see today. These density perturbations should have a constant entropy, or be adiabatic in technical terms, and have constant spatial curvature to near 0%, i.e. not having constant spatial curvature, or isocurve. They should be we shouldn't really observe any isocurvature. We have measured that these density perturbations are adiabatic to 98.7% and isocurved to 1.3%, which are extremely close to the predicted numbers, again providing powerful confirmation of an inflationary epoch very early in the universe's history, as well as corroborating with the line of evidence outlined previously. Fluctuations on supercosmic horizon scales. If inflation did indeed occur, the temperature fluctuations in that cosmic microwave background should exist beyond scales of the cosmic horizon. How would we measure that? Well, we could measure what I believe is called the E-mode polarization of the cosmic microwave background to see this, and we see that these fluctuations do exist well beyond what the cosmic horizon for us would be, which again provides very strong empirical confirmation of an inflationary epoch. The scale invariance of these primordial fluctuations is also very, very powerful evidence for an inflationary period. Something called the scalar spectral index, which measures the variance of these density perturbations, or rather these primordial fluctuations in space-time. We can measure them, the variance of those, as a function of scale, how large or how small you're choosing to go in the universe. And what we measure is that amongst all the scales, it's about 0.965, which is very, very close to 1 corresponding to perfect invariance. So we see that space-time, or rather the primordial fluctuations that would have existed very early in space-time, and the density fluctuations that they gave rise to today, are near perfectly scale invariant, which is, like I said earlier, strong empirical confirmation of inflation, and it robustly corroborates all of the aforementioned evidence that we've outlined thus far. The third part of my introduction, examining the preponderance of the evidence. Given that the very equations we have that accurately and precisely describe spacetime, when describing a spacetime that looks like ours, give us a spacetime that is expanding, given that we have directly observed and accurately measured the rate of the expansion of spacetime through galactic redshift, given that we have directly observed one of the foremost predictions of the hot Big Bang model, the cosmic microwave background, and given the abundance of hydrogen in the early universe, we are justified. Given all four of those conclusions, we are both epistemically and empirically justified in concluding that the universe was, indeed, very early in its history, in a very hot and very dense state from which it evolved into the universe that we know and love today. Given the four direct, empirically confirmed predictions made by inflationary theory, we are thoroughly, again, epistemically and empirically justified in concluding that inflationary theory not only works as a solution to problems with the hot Big Bang model, but actually further explains things that we can see in our universe today, which is itself powerful evidence that an inflationary epoch likely occurred very, very early in the universe, even earlier than the hot Big Bang phase. In conclusion, the preponderance of all of the empirical data that we have, the direct observations that we've made, and the mathematics which backs it all up, all of that explicitly corroborating each other very, very profoundly, points directly to the conclusion that our universe was, very early in its evolution, in a very, very hot and very, very dense state, to which we can extrapolate back roughly 13.8 billion years. We also know from the empirical evidence that we have seen and the predictions that we have been confirmed that the inflationary epoch proposed initially by Alan Guth in 1981 solves problems with the Big Bang and further describes an expanding spacetime that was, again, very early in its history in a very, very hot and very, very dense state from which it evolved. And that is what the Big Bang, that is what modern cosmology tells us. So those who wish to set aside any of their personal biases or beliefs or convictions and follow the preponderance of the evidence that we have and all of the mathematics that backs it up, I think will come to accept the physical model that I have presented and defended here tonight and the conclusions drawn from it. Thank you.
I appreciate that opening statement, Leo. Perfect timing, and I appreciate that. Also, to the audience, we've already got over 225 people in the chat. So please, if you are asking me questions, just make sure you're tagging me at Standing for Truth so I don't miss it. That being said, we're going to hand it over to Kent. Kent, you also have a 12-minute opening statement whenever you're ready.
Me here. We're discussing the Big Bang. Although the Big Bang theory is widely accepted, it probably will never be proved, consequently, leaving a number of tough unanswered questions from some NASA sources here. So I appreciate Leo for doing this tonight. I think he's missing the absolute major point, missing it completely. The Bible says 17 times God stretched out the heavens. I agree. He stretched out the heavens. Big Bang theory does not answer any of the major questions. Where did matter come from? Where did energy come from? He talks about all the gigavolts in the original thing. Where's this heat coming from? Where's this energy? Where's the space coming from? Absolutely bypasses all of that. He does not have a complete theory that doesn't explain the beginning. In my previous sessions, I talk on creation evolution. I talk about the first law of thermodynamics. Matter cannot be created or destroyed. Leo's theory completely violates that. Where did matter come from? Just to say it's there, it doesn't answer the question. So you do not have a complete model. Where did matter or energy come from? Matter or energy cannot be created or destroyed. So, two choices. Somebody made all this, or the world made itself, which is what Leo is trying to present to everybody here with all the big words and fancy phrases. Oh yeah, it just made itself. And we know that because it's expanding and hot. Think about it, okay? We're here, okay? We really are. I don't think the Berkeley folks understand that, but we are here, okay? Bible's real simple. In the beginning, God created the heaven and the earth. I take this on faith. I admit freely I have a religion. I doubt Leo will admit his is a religion. He will probably think it is science. No, Leo, you have a religious belief that matter can create itself, and space-time can create itself, and energy can create itself. You have a religious belief and will never admit that, okay? Humanist Manifesto. Humanists regard the universe as self-existing and not created. Okay, well then, how'd you get here? And their answer is the Big Bang, which is what you're supposed to defend tonight. Now, I don't mind if people want to believe the Big Bang. Leo, you're welcome to believe whatever you want to believe. But keep in mind, these people like Leo who believe in the Big Bang, in complete violation of any scientific proof of this, they want to force everybody to teach this to all the kids in our school system. No, Leo, you should keep that at home and teach it in a private school for those who wish to learn Big Bang. It's got nothing to do with science. So matter cannot be created or destroyed. First law of thermodynamics says energy, i.e. Heat or energy, cannot be created or destroyed. You can read all about the first law of thermodynamics on your own time. Bible says, thou, Lord, in the beginning laid the foundation of the earth, and the heavens are the works of thy hands. The Bible clearly claims God did it. Now, if you choose to not believe that, that's okay, but don't claim you have a scientific reason for rejecting that. Of old, it says in Psalm 102, thou hast laid the foundation of the earth, and the heavens, they are the work of thy hands. They shall perish, but thou shalt endure. It's true, everything we've observed says heavens, everything is perishing. It's getting worse. That's the second law of thermodynamics. Everything is falling apart. Take a look in your sock drawer if you don't believe me. Everything tends toward disorder. Go look in our shop. Yeah, everything tends toward disorder just automatically, okay? Most thinking people today know it is dumb to worship a dot of nothing that exploded into an ordered universe of life. But they teach, like Leo taught tonight, the universe came into existence. No, stop right there. You can't just make a statement like that without some scientific proof. They say 14 billion years ago. This guy says 13.772. Leo said 13.78 in 3 weeks or whatever it was, okay? So I think it's dumb to worship time, space, energy, which is what they are doing. 13.8 billion years ago, the universe came to existence. Now, as far as the age of all this stuff, we can discuss that some other time. My video number 1 gives about 40 different reasons how to prove the Earth and the universe cannot be billions of years old. It can't even be millions of years old. If I told you this ink pen was 10,000 years old, I think you could pretty quickly disprove that. You could say that's a Bic pen. Bic wasn't even a company till after World War II. Oh, well, you just proved my claim of thousands or millions of years wrong. Has to be after World War II. We can go on through all that, but I think we could demonstrate clearly that the time is not there for their theory to take place anyway. If you take away time, that is like taking away the pacifier from a baby. Get this thing open here. Time, that keeps them happy. I'm given millions and millions of years, anything can happen in their mind. Well, that you can't have the time, but even if you did, it wouldn't happen. So major evidence to support the Big Bang comes from Hubble's discovery in the 1920s of the galaxy's relationship of distance to Earth and its speed. And the background radiation, Hubble did a lot of work on that stuff. Hubble's brilliant observation was that the redshift of galaxies was directly proportional to the distance of the galaxy from the Earth. That meant the things farthest away from the Earth were moving away faster. I would agree there is a redshift. I would agree. What that means is, well, I'll get to my other slide here and show you. Redshift. This is the big thing that, let's see, Alt-DV 277, enter. How do we see the stars billions of light years away? The Bible clearly claims 17 times that God stretched out the heavens. When you look at the star through a telescope, we've got some pretty good sized telescopes here at our science center in Dinosaur Adventure Land in Lenox, Alabama. You get the biggest telescope you can find and look at the closest star, Alpha Centauri in the Proxima Centauri group. All you see is a dot. It never gets bigger. You never see the flames leaping off like you do on the sun. You just see a dot. Stars are a long ways away. I want to get to supernova here. Let's see, I cover all this on my video number 7. How many supernovas have been observed? Let me go back to home and go to redshift. There we go. Okay. So what is the redshift? If you look at the star and you bring the light in through a spectroscope and break it up into the colors of the prism, you'll see there's lines on there, and they're shifted over toward the red. What does that mean? Well, that's an indication of what's called the Doppler effect. Okay? If you're sitting at a train track and the train's coming toward you, the sound is compressed and it goes, and when it goes past you, the sound is stretched out and it's refracted. So the sound from the Doppler effect of the train is, you've all heard that in various things. Whether you're moving past the train or the train's moving past you, it works either way. So we talk about the absorbed material, the redshift, more if you'd like, but I got plenty of that on video number 7. It's a redshift. Okay. So clocks, gravity, and limits of relativity. Human world, space. What is a redshift? What is a redshift? Let's see. The light from nearly every galaxy, as they see, it looks like, because the Doppler effect, it looks like the stars are all moving away. They all exhibit a redshift. So they've said, wow, that proves they used to be closer. A reasonable assumption, not proven, but a reasonable assumption. So if we're standing here on the Earth and all the stars appear to be giving a red shift, and that looks like, wow, all the stars are moving away from us. Well, then that would fit the Bible model that God made the earth first on day 1. He made the heaven and the earth, Genesis 1:1. And then he made the stars on day 4, and then he stretched them out. So if he made the earth and then he made the stars and stretched them out, we would see a red shift in every direction, wouldn't we? Yeah. So they made up these, Hubble matched up these red shifts with distance estimates. Just because you see a red shift, you can't measure the distance from that. The way they measure the distance, Bible says God stretched out the heavens. He stretched out the heavens. Here's the deal. The light from the star coming toward us should get, everybody's asking the question, how did the light get here from that star? It must be billions of light years away. They're asking the wrong question. Instead of how did the light get from the star to here, the question is how did the star get from here to there? If God made the earth first and then he stretched out the heavens, the question is, he made the stars after the earth and stretched them out into place. Of course, there's a red shift. Students are never taught that. First law of thermodynamics. Okay, let's see. How can galaxies be speeding up? They're teaching that the farther away the galaxies get, the faster they go. Where are they getting the fuel to speed this up? How do you speed up a massive object like a star? This is simple physics, Leo. You have to have energy added to it to speed it up. Is it expanding towards something else that's attracting it? If so, what made that other thing out there that's attracting it? So the idea that the universe is expanding and increasing in velocity, you guys got some real questions you better answer. Matter cannot be created or destroyed. Let's see. We can talk forever about that if you'd like. Okay. Certainly the most famous equation in all of physics, perhaps the most important, the force equals the mass times acceleration. Where, if the mass of the star is accelerating, where's the force coming from? Where did it go? Let's see. I want to get to right here about the redshift. God said he stretched him out. He stretched him out. Okay, here's the redshift. If it works with, as far as we know, it works with sound, we know. We think it probably works with light. By breaking up the colors of the rainbow, and you see the redshift shifted over toward the red spectrum, the train analogy, coming toward you, compresses the sound, leaving you, it refracts the sound or stretches it out. I understand all that. If it's coming toward us, it should give a blue shift. Okay. There was an early indication, early sign that redshifts indicate distance to galaxies. However, the diagram shows a wide scatter in apparent brightness at every redshift. In fact, there's little correlation of brightness to redshift at all. So quasars come in extremely wide luminosity, intrinsic luminosities, or redshifts do not indicate distance. Do the redshifts tell a distance? Here's the problem with measuring the distance to a star, and I give a long diatribe on this on video number 7. Let's see. All right. Let's see. The redshift might be stretching from the creation. It might be the light is getting tired traveling those great distances. It could be the effects of traveling great distance through space, whatever space is made out of. Okay. I get tired when I travel through the water and swim a long way. The Doppler effect could be light is slowed down or speeded up by gravity, like a black hole or dark matter, purely theoretical. Robert Gentry has a great article on that on halos.com. Let's see, right here. So the way they measure the distance to a star is try to get the angle. It's called the parallax trigonometry. As you go further out, the distance would be greater if, simple trig, I taught trig for years, okay? How did they ever form into clumps like stars and galaxies? If the Big Bang is true and everything is spreading out, well, the longer you wait, the further apart they get.
1 minute.
So how can they get back together to form a galaxy? I think you got a real problem here. You guys want to claim that everything got together by gravity. Who made gravity? And the Big Bang would absolutely destroy it. All we'd have is a giant cloud. The universe would be a bunch of dust particles floating around out there. If the Big Bang were true, they would never get together. And I meant to get to, well, if I see a car headed east in Pensacola at 70 miles an hour, does that prove it started in Los Angeles 30 hours ago? No. What we see is stars giving a red shift. And then what they want to think is we can go back millions of years and they all started in a dot. That's where the stupidity comes in to the whole Big Bang theory. All right, I yield my time.
All right, I appreciate that opening statement, Kent. That concludes the 12-minute opening statements. Gentlemen, thank you so much for the visuals and great presentations from the both of you. So that being said, we're now moving into the first uninterrupted rebuttal. We've got 8 minutes on the clock. And Leo, whenever you're ready, the floor is yours.
Awesome. So Kent asks initially, where did the mass and the energy come from? Well, I don't know if anybody else in the audience remembers. I certainly do. The very first thing, the very first caveat that I gave in my introductory statements was that contemporary cosmology does not address that question. It's a meaningless question to ask in regards to this debate, as the subject of this debate simply doesn't deal with it. It couldn't. We don't have any physics to describe where mass energy came from, or whether or not that's even a meaningful question to ask. I believe Kent said something along the lines of like cosmology violating the first law. It doesn't, primarily for the reasons that I just outlined, that it doesn't address where the mass and the energy came from. Also, thermodynamic laws apply to things within space-time, but they do not apply to space-time itself as a whole. He also presented a false dichotomy when he said that we only have two choices: either it made itself or it was created. The third choice is that the universe could have existed tenselessly. It just is as a brute fact or a brute contingency, or it could be that the universe is eternal to the past in some way. So that would be a false dichotomy on Kent's part to limit it to just those two options. I don't have a religious belief. I don't adhere to any doctrines that prescribe the worship of a deity, which is how religions are defined by the Oxford and the Cambridge English dictionaries. And I have never claimed thus far in this discussion that mass, energy, and space-time can create themselves. So I don't know why he's mentioning that when I never made that claim. He also said that the second law of thermodynamics tells us that everything tends toward disorder. This isn't really correct. What the second law tells us is that systems containing the ability to do work, as they do work, we'll see that ability to do work decline. And this only applies on a global scale. So for instance, the Earth, or really any of the planets in our solar system, are not closed systems. They are actively receiving energy from the sun. Also, I didn't state that the universe came into existence. Again, I outlined initially that we don't. That question doesn't mean anything to cosmologists right now. We don't have answers to that. Nobody does. People might think that they do, but nothing empirical. If you want to think that your answer is correct, there's nothing wrong with that, but nobody, scientist or otherwise, has any empirical data to back up any of their claims concerning that. Also, galactic recession is not a result of added energy into the galaxies, because again, the galaxies themselves are not moving. The space between the galaxies is expanding. Their movement comes from existing in space, which is itself moving. And space-time simply expands because of the energy intrinsic to it that we call dark energy. He also mentioned the concept of tired light, which just doesn't work. Electromagnetic radiation propagates at a constant speed through the vacuum of space. There would be nothing for it to resist and for it to slow the light down. Also, stellar formation, which he touched on briefly, isn't really relevant to this discussion. How stars form doesn't matter to the very earliest moments of the universe when stars didn't yet exist. So just to conclude my first rebuttal, I didn't really hear Kent give a model explaining any of the observations that we've made. He didn't provide a model that can make testable predictions that we could confirm through experimentation. And if he wants to contend with the concordance model, with the standard model of cosmology, he's going to need to propose a model himself that at least as well, it hopefully better explains the observations we make and has more accurate mathematical theorization behind it. And at least thus far, he has not yet done so, and I will yield the remainder of my time.
I appreciate that rebuttal, Leo. And as we always do, whatever time is not used for the uninterrupted portions, we toss into either the discussion or the Q&A. And we've got a lot of great questions coming in, so it should be a good Q&A. Kent, I'm going to restart the clock, and you have up to 8 minutes. Whenever you're ready, let me unmute you real quick, Kent. Okay, you're good to go.
Well, thank you so much. Yes, Leo, I heard very clearly your first statement that you do not know where time-space matter came from, which is what I pointed out. Therefore, you have an incomplete theory. You cannot force what you believe to be taught to everybody as if it's part of science when it doesn't have a beginning. You don't know. To say that it's eternal obviously would violate the obvious, everything's decaying, everything's falling apart, the second law of thermodynamics. Things get worse with the energy is being used up. It's being dissipated as heat and lost for use. You said that the galaxies are not moving away. The space-time is expanding. I've heard that that's one of the dumbest statements anybody's ever made. I've heard that for 30 years now. It makes no sense to anybody that ever hears it. We're not getting farther apart. The space between us is increasing. Think about it. Okay. Space is expanding. Well, you can say that and believe that, but that's not science. That's a religious belief. Okay, the speed of light is not a constant. 186,282 miles per second. The researchers say they slowed light down to a dead stop. This was back in 20 years ago, in 2001. Let's see. The achievement was a landmark feat, reined in by nature's swiftest, most ethereal form of energy, and for the first time could help realize what are now theoretical concepts for vastly increasing the speed of computers. Oh, okay. 2 independent teams at Harvard University and another university, I can't pronounce the name, said at Smithsonian did it. And also at Cambridge in astrophysics. We have succeeded in holding a light pulse still without taking all the energy away from it. This is 20 years ago. Okay. Eureka, scientists break the speed of light. Back in 2000, they claimed to have broken the ultimate speed of barrier, the speed of light. They speeded light up to 300 times the speed of light. Oh, okay. By running it through cesium gas, etc. Okay, let's see. The speed of light has apparently decreased so rapidly that experimental error cannot explain it. During the last 300 years, 164 separate measurements of the speed of light have been published. When I was teaching high school physics, we used to measure the speed of light in the hallway with rotating mirrors and a laser. Okay, not that hard to do. So if the speed of light is decreasing, University of Glasgow, scientists slow down the speed of light traveling through the air. That was a couple years ago, 2015. Scientists mess with the speed of light from Live Science. Researchers in Switzerland succeeded in breaking the cosmic speed limit by getting light to go faster than, well, light. Scientists have recently succeeded in doing all sorts of fancy things with light, including slowing it down, even stopping it altogether. Now a team from this place in Switzerland is controlling the speed of light using simple off-the-shelf optical fibers and running it, let's see, without the aid of special media like cold gases or crystalline solids, etc. So I don't think you could prove the speed of light has always been the same. Scientists cannot measure distances accurately beyond about 100 light years. With simple trigonometry, you cannot go beyond about 100 light years and measure those distances. It can't be done, okay? It's too narrow of a gap. The angle becomes too small. Nobody knows what light is. Jesus said he is the light of the world. Maybe God is doing all this, but that would be a religious belief on my part. And I'm not asking everybody to pay for my religion to be taught. You guys want everybody to pay for your religion to be taught. And you don't have an answer to where time, space, matter came from. So you have a religious belief that it's either always been, eternal universe, which of course it's not scientifically provable, or it came into existence by itself from nothing, which again is not scientifically provable. Yes, I heard your opening statement, and I think it was a great confession on your part that you'd have a religion. Okay. When the creation was finished, it was mature when God made it. Jesus made wine out of grapes that never existed, aged in time that never was. So my Bible says, in the beginning, God created the heaven and the earth. 10 words, first verse. I take that by faith. I take it. I think that's the best scientific answer we've got. You don't have a scientific answer for the origin of time, space, matter. Keep in mind, a light year is a distance. It is not a time. It's the distance light travels in a year. It's like a Hovind minute. How far can Hovind run in a minute? That number is decreasing over the years, but it used to be pretty good back in the day, okay? The speed of light is not proven to be consistent, so why would star distance have anything to do with the age of the universe? If a star is 13.772 billion light years away, which we can't measure, but if it is, God could have made it 10 seconds ago or 6,000 years ago and then stretched it out into place. It would not prove the universe is billions of years old because of a star distance. Okay, keep that in mind. The redshift only shows that nearly all stars are moving away from the earth. That fits the creation account perfectly. God said, behold, I create heavens and a new earth. New heavens, new earth. The former shall not be remembered. As the new heavens and new earth which I will make, he said in Isaiah 66. Heaven and earth shall pass away. My word shall not pass away. So I will present a scientific theory. I believe if we start with the assumption God created the heaven and the earth, and then he stretched it out, like he said, well, all the science will fit that scientific assumption. You start with an assumption that we don't know where time, space, matter came from, but it's expanding away from each other. The galaxies aren't moving, but the distance between them is increasing. If anybody understands that, let me know. And all this heat and energy, not just all the mass, all the heat had to be in that initial dot. What's the total temperature of all the stars in the universe? Leo, you couldn't squeeze this rock into a dot smaller than a period on a page. I'll give you $1,000 if you can squeeze a gallon of milk into a dot the size of a period, let alone the whole Pacific Ocean, let alone all the planets and all the stars. And Earth's a tiny planet compared to some of the big ones. You want to get all of that in a dot just because you see the universe expanding. I agree it probably is expanding, but that doesn't prove it all came from a dot. If a car is going east on I-10 at 70 miles an hour, that doesn't prove he started in Los Angeles. So the Bible says the heavens are going to be dissolved and he's going to make a new heaven and a new earth. He opened up the sixth seal, the moon became his blood, and the stars of heaven fell onto the earth. That's what it says in Revelation going to happen. So Leo, I don't know if you're prepared to face God when you die. You will die one day. I hope it's a long time from now, but it'll happen. It's going to happen to me. Then what? Are you content with your religious belief, all the stuff you studied? Are you content that this is enough to say that God's word, my Bible's in the other room, you're content to say that you're going to reject the Bible, which millions accept, in favor of it all came from you don't know where, okay? The universe is not billions of years old. The Bible dates add up to about 6,000. Starlight distance does not indicate billions of years, does not prove it, and redshift does not prove billions of years. The planets cannot be billions of years old. They're losing heat. They're slowing down in their spin. The moon is getting further away from the earth. Moon cannot be billions of years old. The earth cannot be billions of years old. Life on earth cannot be billions of years old. There's all kinds of scientific limits on these things. I'm sorry that you've chosen to believe that, but I think you're wrong. And I'm here to convert you tonight. Okay, go ahead.
All right, I appreciate that 8-minute rebuttal, Kent. That concludes the first round of uninterrupted rebuttals. We're now going to move into a second uninterrupted rebuttal, this time 4 minutes. And we're going to hand it over to you, Leo. Whenever you're ready, let me know, and I'll start the timer.
Yeah, I'm ready to go. So I did want to say that I specified nobody knows where time, space, and matter came from. We might all have our own beliefs about that, but none of us can confirm that. So I mean, he says that, yeah, I heard you mention that. Then why do you keep pressing a point that's already been conceded? You then said, well, then you have an incomplete theory. There isn't a single theory, or at least there's very few theories that humans have that are complete. General relativity is incomplete. But if you want to take issue with the accuracy of Einstein's field equations, I invite you to publish your work. That's one of the dumbest statements he said to when I explained that the galaxies aren't actually moving, it's space-time expanding. That's just not a response. I would wonder if he has one here, or if he just plans to merely hand wave away something that maybe he can't respond to, and that's why he just kind of hand waves it away. The speed of light is constant for anybody that understands special relativity. What would give us that is the equation C equals the square root of 1 over epsilon naught mu naught, which tells us that the rate at which electromagnetic radiation propagates through the vacuum of space-time is dependent on the structure of space-time and its ability to permit an electromagnetic field through it. This is nothing new. Also, yeah, we have slowed down light to practically not moving at all, but that's because we're changing the medium through which it travels. Again, light only travels at C, specifically in the vacuum of space-time. Kent gave many examples of where we put light through very, very dense mediums that slow it down to practically not moving at all. But none of that means that light does that when it's traveling through the vacuum of space. Hint, it doesn't. We know, we measured. In terms of measuring these extreme distances that Kent measured, we don't really need to use trigonometry, but even if we wanted to, we use supercomputers to calculate those extraordinarily small angles, and you can make them arbitrarily small and they're still calculable. So that doesn't really overturn anything. Also, we tend to use like gravitational lensing measures, standard candles, numerous other methods for measuring these extreme distances because we're in the 21st century now. We don't need to use the basic trigonometric methods that they were using 90 years ago. Also, we've put more energy than 1 billion nuclear warheads into a point smaller than a proton before. We've done that. It's probably happening right now at the Large Hadron Collider at CERN in Switzerland. This is how we found out the internal structure of protons. The energy present when 2 protons collide is, I mean, we're talking on the order of tens of trillions of degrees Fahrenheit for a fraction of a second. So we have put much more energy that is contained than what is contained in a gallon of milk into something significantly smaller than the period on a sentence. I don't know what Kent is talking about. If he taught physics, he certainly didn't teach particle physics or high energy physics. I've noticed that he still hasn't presented a model, nor has he provided any reasonable objections to the model that I've outlined or the empirical data that confirms its accuracy. At this point, I wonder if he has one.
All right, I appreciate that 4-minute rebuttal, Leo. Time really does fly by, I know. Gentlemen, great debate so far. We've got over 300 people in the chat. People are loving this. This certainly is, this is epic. It's a big one. So we're going to hand it over to Dr. Hovind. You now have 4 minutes of uninterrupted rebuttal.
All right. Well, thank you, sir. I have no problem claiming the heavens declare the glory of God. I don't have any problem stepping outside, looking at the stars off our sand dune out here where we have a special deck for looking at stars with no light to distract you and say, wow, God, you're amazing. Okay. When I consider the heavens, the work of the fingers, the moon, the stars, which thou hast ordained, what is man that thou art mindful of him? See, when I look at the stars, I realize how small man is. I think when Leo looks at the stars, he thinks, oh, we are God. We're in charge of the universe. We're it. We've evolved to the peak, from the stardust for some reason, okay? Anyway, so when you look at the stars and you want to calculate the distance, okay? Now, that's another long, okay. Where did I get off? Okay. There. Now I want to get that, okay. Trigonometry, I did teach trig for a long time, Leo, and I think if you have a different method of measuring these distances on your supercomputer, I understand you can measure angles if you know the points, but you don't know with simple trig, to measure an unknown distance, you have to have at least one side and 2 angles or 2 sides and 1 angle. If you're looking at an object, when hold your right eye and left eyes, just blink right eye, left eye, you will see it appears to move in the background. That's called parallax trigonometry. Problem is, with your eyeballs, you get them crossed if you go too far. Okay, the Earth is about 8,000 miles in diameter. That's as far away as you can possibly get from anybody in a straight line, 8,000 miles. 7,926 if you want to be precise, depending if it's polar or equatorial. Okay, so to get a bigger angle on their telescope, to their star distance, they look at the star in January and then look at it again in June, and now you are 16 light minutes away from where you were. It takes light 8 minutes to get from the sun to the Earth. But if you orbit around the Earth, around the sun one time, you now have a much bigger base on your triangle, 16 light minutes, much bigger base. That's the biggest base we can possibly get. Okay? So 1 light year, 1 year, has 525,948 minutes in it. That's a year. If that little yellow dot was Earth's orbit, not the Earth, the orbit of the Earth around, and you're trying to measure 1 light year, let's see. Let's change all this light minutes to inches. 16 inches represents 16 light minutes. 1 year would be 525,000 inches, which equals 8 1/3 miles. So if you think you can measure the distance to something 8 1/3 miles away, using only 2 observers, 16 inches from each other with 2 telescopes, and the only thing you know is you're 16 inches from the other guy, and you want to measure the angle of declination between your 2 telescopes, like your eyeballs going crossed, okay? How far crossed would they be for 8.3 miles? That's a pretty skinny angle. And I don't think you can tell exactly where you were 6 months ago either. So a year around the sun, 1 light year is an angle of 0.017 degrees. Okay, let's say we can measure that, 0.017. From a moving Earth spinning around, depending upon your latitude, here's about 886 miles an hour at Lenox, Alabama, 31 degrees north of the equator. But depending on your latitude and your velocity, and plus your velocity going around the sun, plus there's the sun going around our galaxy, and you're going to try to measure off of this moving object. Get in your car, go 100 miles an hour, and try to calculate the distance across a cornfield with parallax trigonometry with a car going 100 miles an hour. Okay.
30 seconds.
Yep. 2 surveyors in Florida, both of them looking at a dot in Chicago, would be the equivalent of 100 light years. You guys make up these numbers of 15 billion light years, and I don't think you can tell those distances. I'm sorry. They may be that far away, but we don't know. And all they're using is redshift. I disagree completely. I'd rather give God the glory for the stars. Go ahead.
All right. Perfect timing. Thank you so much, Kent. That concludes the opening statements and 2 uninterrupted rebuttals. We are now moving into a discussion portion. As always on this channel, we strive to keep these discussions equally timed and professional, of course. Let's start by asking each other questions and allowing enough time to answer each question. We will do our best to make sure each debater is asking the questions they feel are necessary given the topic. Kent just ended with his rebuttal, so let's hand it over to Leo. Maybe there's a couple points you wanted to address, or a question, and a question you might want to ask. So, gentlemen, the floor is yours.
Yeah, for Kent, do you know what standard candles are in cosmology?
Yeah, the brightness of how compared to a standard candle, they look at a light and see how bright it is. If it's the same light, if you know it was the same intensity of light but further away, it would give a diminishing return. The standard candles. Yes, I'm very familiar with that. Go ahead.
And so you do realize that when we're talking about extreme distances, that's generally the method that we use.
So you're saying you measure the distance to these stars based on how bright it is.
Well, not the star that we're measuring. Stars whose have a known intrinsic brightness that doesn't change relative to those distances. Wait, okay, do you think that we're getting like exact to the inch measurements on these distances, or do you think that it's probably within maybe a few million miles?
I did not say that. I did not say they're getting exact to the inch measurements. And as I've said,
that's why I was asking.
Well, okay, the stars might be billions of light years away. They could be. The numbers could be accurate, but that wouldn't mean anything has to do with the age. That's a distance. That's all. So if it was created right there 10 seconds ago, 14 billion light years away, it could be 10 seconds old. You're confusing distance with age.
We don't use distance to the stars to measure the age of the universe, Kent.
How old is the universe, Leo?
We don't know how old the universe is. What we can say is that we can go back to roughly about 13.8 billion years ago. Whether that's the beginning or whether we can go back even further, we don't know yet.
What do you mean you can go back 13 point? I'd love to go back 5 seconds many times in my life and undo the dumb thing I just did. You can go back in time.
Excuse me?
I'm trying to understand.
Wait, when did I say we could go back in time? Do you not know what inverse means? Do you not know what it means to extrapolate back?
I do.
Like if somebody said, "Hey, let's go back to when you were in high school" in a discussion, do you literally think that they mean that you're time traveling, or do you think that they mean let's talk about
in
this
your
moment
mind?
in the
Okay,
past?
no, it's in your mind. You go back to high school. I can remember that vaguely.
Yeah. So when we
ago.
say let's go back to the Big Bang, what we're saying is let's inverse back to the moments that we call the Big Bang. We can do that by taking the expansion rate of space-time, inversing the functions, which would give us a contraction, and we can go back to where we can't contract anymore. That point, like I said in my opening statements, when we correct for, modern observations, dark matter and dark energy and the accelerated expansion of space-time, we have to correct for those to the initial derivations to be accurate. We get about 13.78 billion years. Yes.
Okay, so this is assuming that you can measure the distance accurately based on either luminosity, candle power, or
measure what
parallax
distance?
trigonometry. Or what about that? You admitted that light can be speeded up or slowed down by going through different mediums. Do you know what's out there in space in all the different mediums? Could it be the light is? Could it be that 500 miles off the surface of the Earth going through something thicker?
Well, for the most part, we do. But you said you how do you get times measuring the distances of what?
No, I'm asking you, do you know what the medium of space is? If the space-time is expanding, is it therefore growing less dense?
No.
I mean, most things, when a balloon expands, the molecules are further apart. Is the space-time, is it becoming less dense, so therefore light would travel faster or slower?
Is space becoming less dense, or are the things
you,
in space becoming less dense as they're carried by expansion?
No, you are claiming space-time is expanding. I'm asking, do you know what the medium is of space-time, whatever that is that light is traveling through?
Yeah, I'm asking for clarification to figure out what it is that you're asking me.
Are
you asking me if it's the space-time itself that's diluting, or are you asking me if the things in space-time are diluting under the expansion? Because those are two different questions.
Right. If space-time is expanding, then is it becoming a less dense medium, therefore affecting the speed of light, therefore affecting your measurements?
No, space-time does not get less dense.
Space-time is expanding, but it does not get less dense. That
is correct. That is because it is a metric expansion of the scale in space-time. You cannot think of the expansion of space-time as if it were an object growing physically larger in some pre-existing space. That is simply not what the expansion of space-time is.
So, in your theory, space-time is expanding into what? What's on the other side?
It's not expanding into anything because, again, space-time is not some physical object physically growing, physically larger in some otherwise pre-existing space. It is a metric expansion of the scale of space-time that is measured over sufficient distances. It is an intrinsic expansion.
Can you explain space-time to an average person? What is this exactly? Use some different words besides space.
We don't really know, other than that it is a four-dimensional manifold that, at least classically, all of the mass energy that we see is weaved into. It is a dynamic manifold. It can be affected by things inside of it. It can affect things inside of it.
Wait a minute. So the mass and the energy are woven into space-time, but you don't know what space-time is.
No, physicists do not know what space-time is ontically.
Okay. Do you know that space-time even exists?
Yes.
Where's the evidence for that? I'd like to see that.
General relativity, the fact that it can be curved under the stress from mass and energy.
So space-time, which you don't know what it is expanding. The galaxies aren't getting farther away. The space-time between them is expanding, but you don't know what it is, and there's stuff woven through it, and it's curved.
Space-time is curved.
You just said,
generally, well, we can measure curvature in space-time as a result of mass energy. Yes, that's what we call gravity. If space-time wasn't a real thing, what's being curved?
So space-time is being curved because of gravity.
So because of mass energy. Gravity is the curvature.
Okay, so gravity has an effect on this space-time that you believe in?
No,
gravity has an effect
mass
on
and
it.
energy
Things
have
are
an
woven
effect.
through it, and it's expanding. But you know the speed of light has remained the same all through all that, all the time, don't you?
Mm-hmm. Yes, we do.
Oh, you do? Okay.
Mm-hmm.
Did somebody go out there and measure it?
What do you mean by measure?
Is anybody out there measuring? How do you know the speed of light isn't increasing or decreasing just 1,000 miles from here?
Because we know how propagations through the electromagnetic field behave in the vacuum of spacetime.
Well, they've demonstrated the propagation of the electromagnetic field, light going through different mediums changes.
Mm-hmm. Mm-hmm. That is correct.
there's nobody out there who knows what space-time is 10 million light years from here.
We don't need
Could
to
it
know
be
what
bigger?
space-time is to know that light moves at a constant speed through its vacuum.
So if it's a vacuum, then its space-time isn't anything.
Well, a vacuum
Space-time
simply
is a
means that
is
it's
it a vacuum?
absent.
How can stuff be woven through it if it's a vacuum?
Wait, hold on. First off, when I said woven through it,
How can it be curved?
I'm speaking metaphorically. Like you
Okay.
said, speak to somebody who that doesn't understand the techniques. That's what I'm trying to do. Also,
Well, I would
what
point
was
out
the second thing
nobody
that you said?
understands what you're trying to say, including you. Okay.
What was that? I didn't catch
I
that.
said nobody understands what you're trying to say. There is no such thing as space-time. You don't even understand it.
What do you
but
mean there's
go
no
ahead.
such thing as space-time? Well, the thing is, I've had this discussion with PhD physicists. They seem to understand what I'm saying just fine. Perhaps it's a mistake on your part, maybe?
No, I would like a jar of space-time to put in my science center right here. Can you give me a jar of it?
Yeah, actually, we could do that. We'd need a pretty strong jar and an extraordinarily powerful vacuum pump. Yes, but we could do that.
So if we get an extraordinary powerful vacuum pump and pump everything out of the jar,
you will be left with the vacuum of space-time. Yes.
So the vacuum is, so space-time is actually nothing.
No. What do you mean by nothing?
A vacuum.
Well, if you're just using the word vacuum and nothing interchangeably, I'm going to need to know what you mean by nothing.
Well, no molecules of any kind.
So yeah, but that wouldn't be nothing. You would still have quantum fields.
Okay. Does this air that I'm breathing right now contain molecules that I need? Oxygen, hydrogen, etc., carbon dioxide. But you want me to pump everything out of this jar, and then we're going to call it space-time, and it contains no molecules of any kind, but light travels through it at the same speed, and stuff is woven through it, and it's curved. What if I get a square jar?
Can be curved. Yeah, it would be fine. So I did have a question, somewhat of like a metaphorical question, like an analogical question. If there was nobody on a stage at a theater, do you still have? Is the stage still there?
Does the stage exist if nobody's on the stage? Certainly, yeah.
Okay, it's the same thing with space-time and mass energy. Just because there's no mass energy in space-time doesn't mean you still don't have space-time. Space-time is like the stage, and mass energy is like the actors on that stage. I mean, that's metaphorical. It's more technical than that, but yeah.
I think I understand it as well as anybody, and I think nobody understands it, including you. So space-time is this jar I'm going to put in my science center, which contains a really strong vacuum, really strong jar, pump everything out of it. Now I have a jar of space-time. Light can travel through it, and electromagnetic energy can travel through it, and you know it always goes the same speed, and you know it can be curved, and stuff can be woven through it.
It goes the same speed in a vacuum, yes.
So if my jar was expanding, the distance on the two sides of the jar would not be getting further apart.
Well, depends how large is your jar. I mean, if you're talking about a jar that's hundreds of millions of light years long, yes, your jar would be expanding because the space within it would be expanding, carrying the jar. Yes.
Okay. Well, I could rest my case at this point, but I think that the Bible clearly teaches that God created everything. You're unwilling to give God the glory for his creation and the stars and the matter and everything, including, I mean, if we really came here, if we're just a bunch of random molecules arranged by chance, I don't see how you can trust your own thoughts and your reasoning processes. Maybe you got some chemicals in your brain backwards.
Has to do with cosmology.
Okay. Well, I typically debate on the creation evolution topic, and your Big Bang theory is the absolute foundation for the evolutionists.
I fail to see how it doesn't even concern itself with biology. This is cosmology. This is an entirely different subject.
Right. This is cosmic evolution. The first stage they have to have for their theory is where did matter come from?
Well, I mean, sure, you also have to have a universe to create a pie, but that doesn't mean that pies and cosmology, baking pies and cosmology are somehow related now.
Well, no, the origin of matter to make the pie, I would give glory to God for that. In the beginning, God created the heaven and the earth. So you said you don't know, and nobody knows where your space-time or matter came from. I don't think you even know what space-time is, okay? If it's a vacuum.
No, we don't. I conceded that already. We don't have a quantum theory of gravity.
But you do know things can be woven through it, and it can expand, and it can curve, and light always goes the same speed through it.
We've measured all of that. Yep, we've measured all of that precisely. Yes, we have.
So they have measured light going through different mediums, less dense or more dense, and it changes speed, doesn't it?
Yes, because the photons are interacting
So
generally with the electron shells of the atoms which make up that material. If you don't have atoms in the vacuum of space-time because it's a vacuum, you don't have those interactions and light free streams at sea. Yes.
So the things that are made of atoms, like galaxies, can be getting further away by the nothing between them expanding. I'm sorry, they're not getting further away. What now?
I don't know what you mean by nothing.
Space-time.
Well, space-time and nothing aren't synonymous. I mean, if by nothing you just mean space-time, sure, I can run with that. I just take space-time both physically and philosophically to be something entirely different.
Well, that's why I'd like a jar of it for my science center here. What color is space-time?
What does that even mean? That's like asking me what's north of the North Pole. It's an incoherent question.
Well,
color is a property of electromagnetic radiation reflecting off of something at a particular wavelength. Electromagnetic radiation does not reflect off of space-time with a particular wavelength, Kent. It doesn't have a color. It's an incoherent question.
I'm trying to get it straight now. Nothing reflects off of space-time. It can be curved. It can be put in a jar, and stuff goes through it.
Well, you don't put it in the jar. The jar exists in space-time. So, like, yeah, that's like there's space-time in my hand right now because my hand exists in space-time.
So now my whole science center has to be made out of space-time.
Okay. It's not made out of; it exists within.
It exists in. I would agree.
It's made out of mass energy, which exists within space-time.
Well, I would agree. We all exist in space. I would agree. We all exist in time. I don't think you need to put the two together.
Well, they are put together. That's called a Minkowski space. Yes.
I think maybe God answered that.
Both special and general relativity.
Well, could it be that God answered that in 10 words in the first verse? In the beginning, there's time. God created the heaven. There's space. And the earth. There's matter.
I mean, you can incorporate that into your personal beliefs, yeah, but in terms of putting that into the science, I don't know how you're going to do that because we can't empirically confirm it. Sure, if you want to believe that space-time is created by God, look, dude, I don't have any problems with that, but that doesn't really answer any of the questions that we're posing here in this debate, which is the merits of modern cosmology versus the merits of what the Bible says. And it seems to me that there is literally no empirical evidence supporting what the Bible says, and all of it supports modern cosmology.
Okay. Well, science, the word science means knowledge from the word seer.
I know what it means. Scientia from Latin, meaning to know.
From Latin. What do we know? And what do we know by? What do we know by observation, by testing, by experimentation? We know by observation, experimentation, and testing quite a few things. I love science. I'm surrounded by science books. I taught science 15 years. The Big Bang Theory is not part of science.
What do you mean by that?
There's no, you test it. Do it again.
We already have. It predicted the cosmic microwave background. We've observed that. It predicted that space-time should be expanding. We've observed that. It predicted an abundance of hydrogen and alongside a couple of other light elements in the universe. We've observed that. Isn't that how science works, Kent? You say, look, this is my idea of how this works. If my idea is correct, all of these things that my idea says are true, we should see. Well, look, all of the things that my idea says we should see, we do see. Therefore, my idea must be at least accurate, right? You would agree with that?
Well, my idea is God said he made everything. He made the earth first.
Can you agree with what I said?
Well, just 1 second. Let's just go ahead, Kent. And then we'll
we got questions from the audience, too. My theory says God made the earth first. Then he made the stars and stretched them out into place. So I predict we should see a red shift. Wow, we do. Therefore, my theory is true. Let's all teach the Bible.
Well, what would falsify your theory? What could we observe that would show that you're wrong?
If the stars do not give a red shift,
but that would also show that the Big Bang isn't wrong. So are you just equating God and the Big Bang?
No, you're trying to put the Big Bang on the same level as God. Is your space-time?
I don't understand.
Your nothing expanded, and so time, energy, and matter and space had to have a beginning. You don't have that. Therefore, you have a religion. Why can't you see you have a religion?
That statement is a little off topic. We're not really talking about how did the universe originate. We're talking about the merits, again, of modern cosmology versus biblical cosmology. There are things I could say that would show us that what we think we know in modern cosmology is flat out wrong. Probably not. What could we show that would tell us that what the Bible said was wrong? And if it's all of the same things that would show that the Big Bang is wrong, then I fail to see how we could differentiate between modern science and God at that point. You're just calling modern science God.
Well, no. If man could produce life If life could produce itself, that would prove something, because the Bible says he created living things. God did. Something outside of time, space, matter created time, space, matter. The guy who made this watch is not in the watch, changing the numbers on the screen. He's outside of the watch. Okay? So the God who created this universe he's not limited by my limitations. I'm limited by time, space, and matter, and so are you. We cannot be more than one place at a time. We cannot be more than one time at a time. I can't be here now and tomorrow and yesterday all at the same time. I got to go one day at a time. So I'm limited. I'm traveling through what we think is time, whatever that is, and I'm traveling through space. But I'm still not sure what exactly the space-time is. Why put them together? Just call it space or time. I don't think you need to connect them, but you're welcome. But I'm trying to point out, you have a religious belief. You said at the beginning you don't know where it came from. You said it again later, and you'll say it again now. You don't know where space, energy, and matter came from. Okay, then stop calling it science.
Well, because again, what I'm defending here tonight is not concerned with where it all came from. It's concerned with what evidence do we have that what is being said by modern cosmology is true, because that's the subject of this debate.
Okay, let me
modern cosmology versus biblical. I'm sorry, go ahead.
No, that's fine. Fantastic discussion. Since we are going on an hour and 15 minutes, the discussion portion, I have 2 minutes left on the clock. What I want to do, gentlemen, Kent, take 1 minute to sum up your thoughts just on the discussion. Leo, you do the same thing. And then we're going to jump into some closing statements and then an audience Q&A. Go ahead, Kent, take a minute. Leo gets a minute. Then we're going to jump into closing statements.
I think God created the heaven and the earth, and he ought to get the glory for it. He made the stars. I can look at the stars and say, wow. I think we should also look at all this and say, what does this have to do with eternity? We all have a limited lifespan, 60, 70, 80, 90 years, whatever it is, and then it's over, you're dead. Then what? Leo, then what? Just go back to dust? You sure? Anyway, hope you're content with that. Go ahead.
Go ahead, Leo.
Yeah, my philosophy of mind is not at all relevant to this discussion. I do think, though, I have to say, I think that some of the questions that Kent asks are certainly interesting questions. But look, scientists don't know everything. Yeah, we know that space-time is there. It can be curved under the stress of mass energy. Einstein's field equations describe that perfectly. The fact that we don't know exactly what it is, or if it's emergent, or if it's fundamental, doesn't mean that we can't know things about it. Kent's right. I don't know, nor does he or anybody else in the chat. SFT doesn't know. We might all have beliefs, but we do not know where time, space, and matter came from. Nobody does. However, the model that I'm defending here tonight doesn't make any statements about that, nor was that the particular subject of the discussion. It seems to me that, I just with all due respect, I don't think Kent really has a model here. I think he just has some problems or issues with the model that's been presented. If he does have any further questions, I would certainly encourage him to speak to any professionals in the field. I am not one, and that is why, if anybody remembers from my opening statements, I did cite from reputed professionals and some of the most reputed institutions relevant to the subject on the face of the planet. But I think I've done a sufficient job in showing that modern cosmology, contemporary cosmology, is certainly backed up by all of the empirical observations that we've made, as well as the mathematical equations that we can write.
Okay, thank you, Leo. I appreciate that. Those final thoughts in terms of the discussion, Kent, Leo. Epic discussion, epic debate so far. We've got roughly 340 people in the chat. People are loving it. So what we're going to do, yeah, great job to the both of you. What we're going to do, Leo, if you want to take, for closing statements, we've got up to 5 minutes. If you want to take whatever you need there to for a closing statement, then Kent's going to get a 5-minute closing statement. Then we'll get to a few of these questions. So, Leo, whenever you're ready, go ahead.
Yeah, just to recap quickly, in my opening statements, I outlined 4 pieces of evidence, the predictions rather, that are made by a hot Big Bang model that we have observed. The first one that I outlined was Einstein's general theory of relativity, which, again, and you can go talk to PhDs if you doubt me on this, is one of the single most confirmed, well-substantiated physical theories, physical descriptions humans have ever invented. It gives us, when describing a universe that looks exactly like ours, a universe that is expanding. The galactic redshift that Hubble observed also shows that a universe is expanding. We can take those equations, we can take some of the functions in them, we can inverse those functions. Hopefully people understand what that is. Khan Academy is a great resource for math if you don't. And what we do that, what we get is essentially it's like flipping the clock and you start running it backward, and we can extrapolate backward and we can get back to about 13.8 billion years. I also outlined the cosmic microwave background, which is the direct leftover radiation from the Big Bang. It is, by all rights, effective proof that the universe originated in a very, very hot, very, very dense state. And then I outlined the abundance of hydrogen in the early universe. There are no mechanisms that could have created such an abundance of those light elements, but primordial nucleosynthesis, which is the process that would have released the cosmic microwave background as electromagnetic radiation decoupled from matter. That matter that would have formed those stable neutral atoms would have been mostly hydrogen with a small amount of helium, and the electromagnetic radiation that was released would have traveled through space-time unimpeded, and we can detect that radiation today, and that is the cosmic microwave background. So the fact that those two corroborate each other so strongly is very, very powerful corroborative empirical evidence that the universe originated in a very hot and very dense state. Now, there were some problems initially with that model, but they have been thoroughly solved by inflation. And again, I outlined four empirical confirmations of predictions made by inflation. I'm not going to go over those here for the sake of brevity. But anybody that's interested can examine the sources that I had listed in my opening statements. The Stanford or the Stephen Hawking Center for Theoretical Cosmology is a good one. Stanford University also does have some really good literature on this, as well as MIT and Harvard University. So anybody that doubts me, because I'm not a professional, even though I cited them, I just encourage you to head to your nearest university and sit down with a cosmologist and ask them the questions and see what they say.
All right, I appreciate that closing statement, Leo, with a couple minutes to spare. So let me restart the timer. Kent, you now have 5 minutes for your final thoughts and closing statement. Go ahead.
Well, thank you, sir, and thank you for coming, Leo, tonight. I appreciate that. Scientific evidence against the Big Bang. There's all kinds of it, been published many places. You can go to LPP Fusion if you'd like to read more on that. That's saying that it didn't happen. You mentioned the abundance of hydrogen. Well, hydrogen is the lightest of all the gases, and on the periodic table, number 1. If the Big Bang were true, they say it would produce some hydrogen, maybe some helium, and maybe a little bit of lithium. Well, there are 92 elements, and you can't fuse past iron. So how do you get the heavier elements with your model? With your jar of space-time, I would like my jar of space-time in my science center that we're going to make. We're going to pump everything out of it. I would like it to produce some gold. Yeah, and silver and platinum and uranium. Yeah, there isn't a model where the Big Bang produces all the elements. Even in your model, theoretical model, you might get some hydrogen. How do you get past iron? There is no good model for that. So you can read up all about the problems with the Big Bang theory on the LPP Fusion website if you'd like. There's plenty of stuff, observations that say, look, it's not happening. It didn't happen. So God said he stretched out the heavens. I just have to take that by faith. I believe that's fine. And I think the trusting what God said, I believe if God created us, it's logical and rational that he would give us a book to tell us what the rules are and how he wants us to behave and what he doesn't want us to do, like thou shalt not. If we all came from a Big Bang, where do morals come from? Where does right and wrong come from? Does society decide that? Is it just the majority opinion? The biggest guy with the biggest club or the biggest gun or the biggest bully, he gets to make the rules, right and wrong? Where do morals come from? Is that in this jar of space-time that's expanding and curved and has stuff woven through it? But I just don't think you understand. If everybody believed like you believe, Leo, it would be chaos in society. Like, where's the rules? Where's the right and wrong? Is it wrong to murder somebody? Well, the lion thinks it's perfectly fine to kill the baby zebra and drag it home for its kids to eat. I don't think the zebra likes it. I don't think the baby zebra likes it. Is there a standard for humans? Where's the standard? Where's the right and wrong? Where's the thus saith the Lord? In your model, society would deteriorate to chaos with everybody doing that which is right in his own eyes, like we see twice in the book of Joshua or Judges. So I worry that your theory of Big Bang without a creator is going to be very destructive, and already has been very destructive to society in general. It is this idea that we don't need a God to explain everything. That's the foundation for communism, socialism, Nazism, the New World Order. I cover that on my video number 5. I would encourage you to watch that. That's the one they locked me up in prison for, DVD number 5, about the dangers of this evolution theory. The word evolution is too slippery. There are 6 different levels or stages or meanings to evolution. Cosmic evolution, we've been talking about tonight. We haven't given an answer. Then you'd have to get chemical evolution. How on earth do you get all the different chemicals from hydrogen? Then you'd have to have stellar evolution. The stars have to evolve from this gas that's created. You think hydrogen can be condensed and make a star? There's not enough gravitational attraction. Where did gravity come from, for that matter? But where did the gravitational attraction between hydrogen gas is going to condense to a solid and light up and be a star? Where's the evidence for that? That's not science. That's a religious belief. Then you have to have organic evolution, the origin of life. Somehow, somewhere, life has to get started. No, they can't even do it in the laboratory. And if they do make life in the laboratory, all that would prove is it takes intelligence to make life, which I've been saying all along. You said so many things tonight, Leo. I'd love to discuss with you in great detail. That the universe might be eternal. You said it's not a closed system. Well, by definition, the universe has to be a closed system. Our planet might be receiving energy from the sun, and it is, so we can overcome the second law on the short term. But the whole system is losing energy. The sun's losing energy to send it to us and the other planets. Let's see. You claim the speed of light is a constant, but yet we've shown clearly it can be speeded up or slowed down, and we don't know what space-time is 500,000 miles from here. Maybe it's thicker or thinner there. And you said, we know that everything was very hot and very dense. I'd like you to do some calculations. What is the total mass of all of the stars? And you want to squeeze that into a dot. What is the total temperature of all the stars? You want to get that in that same dot. I think that's hard to believe. I think an average thinking person would say, that's dumb. All right? And I think it's dumb, but that's okay. You can believe it. But I resent having it taught at my expense to all the kids in school. Okay, thank you so much for having us. Go ahead.
I appreciate that, Kent and Leo. Thank you both for your closing statements. And thank you both for an epic debate. Definitely one of the best this year. We've had a great audience, lots of great questions from the audience. So what we're going to do, gentlemen, as we always do on this channel, whoever the question is for, we will make sure they get the last word. Let's say the question is for Kent. Kent can answer it. Leo can give a response, and then Kent will get the last word. And then, of course, the same thing if the question's for Leo. So let me at least make sure I get through these super chats. And let me see here. There are a couple super chats that came in recently, so therefore I can at least get it up on screen. So let's see here. First question comes in the form of a super chat. I appreciate it. Stephen Aker. So this one looks like it is for you, Leo. So he asks, can Leo possibly explain how the volcanism and the magnetic fields of the planets in our solar system can possibly last 3.4 billion years?
Because the dynamic processes which give rise to the volcanology and the magnetic field are still happening. The Earth is still essentially a molten ball. We are a tiny species of apes that have just evolved to live on the hardened slag crust of that ball. And the electromagnetic field, or the magnetic field more specifically, is being produced by the still sustained and continuing magneto-hydrodynamic effects inside of Earth's iron-nickel core. So these things exist because the planet is dynamic and is still cooling.
I appreciate the super chat and the response. Leo, Dr. Hovind, if you had anything to add or a response, go ahead.
Well, I agree. The Earth is still cooling, and that's going to put some kind of time limit for how old it can be. It can't be billions of years old. You can't go back and claim life has been here for millions of years. Well, the planet would have been much hotter. So I think that the fact that the Earth is cooling and still has volcanoes and plate tectonics, there's still a lot of energy being expended. At the same time, we're experiencing a lunar drag. The moon's gravity is dragging us, slowing us down. The tides going up and down on the beach are banging into the beach, slowing us down. There's internal friction with the liquid core with the underside of our continental crust. That is slowing us down. The spin of the Earth indicates it's not billions of years old. The heat of the Earth indicates it's not billions of years old. I think the question is great. I don't think evolutionists can answer that how the volcanism could have been going on for billions of years on a cool planet that's cooling. If I told you my cup of coffee was, poured 3 days ago, and been sitting here and it's still hot, you say, come on. I don't believe that. And I don't believe the Earth is billions of years old. It's still hot. I don't believe it.
Go ahead, Leo. You get the
So
final
just
word.
quickly, he said, well, none of these things show that the Earth is billions of years old. He's correct, because those aren't the things from which we derive the age of the Earth. We derive those through other methods, and those methods give us an extremely precise age. And the fact that things like volcanology and the fact that the Earth has an electromagnetic field and it's still rotating mean that obviously those processes can be sustained over billions of years, because that's literally what's happened.
All right,
And we've seen it in other planets as well. That was my final.
No worries. Thank you, Leo and Kent, for the engagement on that question. So the next one comes in again. This one comes from Mitchell, another super chat. I appreciate the support, Mitchell. So the question again is for you, Leo. Leo, thanks for being a good sport. I think most of these questions are for you. The question is light a particle or a wave? If you say wave, where did light come from, if not matter and or materials to create it?
So despite what people may have heard in popular science books or magazines, wave-particle duality is a bit of a misnomer. Particles are never actually particles. They're always waves. We can just statistically reduce that waviness to within a standard deviation such that we can make meaningful statements about particular observables that particle has. Light is always a wave, and it comes from the electromagnetic field. Light is to the electromagnetic field what a wave is to the ocean, a perturbation in its ground state such that it gains energy.
And thank you, Leo. Kent, if you wanted a response, go ahead.
Well, that raises a giant can of worms then. If light, let's see, you said particles are always waves. So do particles actually not exist? Can I get a particle of, like, is this rock all nothing but waves of light energy? Does it actually exist anywhere, or is it all just waves? I'm curious.
Well,
ahead,
I guess to answer that, technically, yes, all of the particles that make it up are waves in fundamental fields of energy. They're distributions of energy across probabilities. It's just that at the scale that humans exist at, those waves are so small that we can call them particles, and they can make up solid objects. Well, the solid part comes from things like the Pauli exclusion principle, spin statistics theorem, but I'm not here to give a lecture on advanced theoretical
Okay, well,
physics.
Leo, do the light waves weigh anything? Does a light
No,
wave?
photons are massless.
So if I've got a bunch of waves in my hand, how come it feels heavy?
Because those aren't photon waves. Those are made of baryons, my friend. Things like this lighter are not made of light. Light reflects off of them. They're made of protons, neutrons, which are themselves made of quarks, which have mass, and electrons, which have mass.
So the electrons have mass, and the electro propagation through the medium going through the space-time is, so all particles are actually made of nothing but waves.
All particles, well, they're not made of waves, they are waves. They're waves of probabilities in fundamental fields of energy. We call those quantum fields. But
Well,
I mean, this gets like deep into quantum field theory. If we want to move on, we can, because
I'd like to find
this is
out
not
why,
easy stuff.
So why does it hurt when it hits you if it's nothing but waves?
I explained that.
Okay.
Yeah, I mean, I can give you a good lecture series on relativistic quantum field by Tobias Osborne, if you'd like. It's very mathematically rigorous. Kent maybe could follow it. I don't know if anybody else could, but I can link it to you if you'd like.
No, I'm fine.
Well, you guys really are making this the probably greatest debate of all time. So I appreciate the engagement. Next question. I do have one here for you, Kent. This one comes in from Mitchell. Again, thanks for the super chat, Mitchell. He says, question for Kent. What is the inverse square law, and how does it apply to the moon?
Well, the inverse square law is you take the square inverse, 1 over the square. So if I had two objects that were attracted to each other magnetically or gravitationally, and let's say they have a pull of 10 pounds, If I bring them to half the distance, I take that fraction 1/2, inverse it, and square it. It is now 4 times the pull. So if the pull here is 10 pounds, the pull here would be 40 pounds. Inverse square law. The inverse square law, the closer they get, the more the attraction is. This works with gravity, light, and girls. To the moon. Well, the moon is getting farther away from the Earth. That's been measured and observed, okay? Which means if you go back in time, the moon used to be closer. Well, the closer the moon gets, the stronger the gravitational pull becomes. So this makes higher tides on the Earth, makes more lunar drag on the Earth, slowing the Earth down. And eventually you reach a point where they're going to snap together. You cannot hold them apart. Like get two magnets too close, they snap together. So I think that the inverse square law indicates the moon-Earth system cannot be billions of years old, but at the same time, while the moon is leaving us. It's just one of the many factors that indicates, hey, it's not billions of years old, folks. You might need billions of years for your theory, but you can't have it. Get a new theory.
Thank you for that. Thanks for the question, Mitchell. Thanks for the response, Kent and Leo. To be fair, go ahead if you had anything you wanted to add.
Yeah, the inverse square law doesn't have anything to do with the age of the Earth. The moon hasn't been with the Earth since the Earth's formed. It's been with the Earth since maybe a couple 100 million years after the Earth formed. And it's moving away at such a slow rate and will be trapped within Earth's gravitational field for quite some time, regardless of the fact that it continues to move away from us. So it's no surprise that we still have a moon even after 4 billion years.
Thank you, Leo, for the response. Kent, question was for you. You get the last word.
Well, I'm surprised he would say that. All the other supposed theories of the moon's origin, the capture theory, which I think he's trying to insinuate here, that we captured the moon as something from orbit. Did the moon break loose from the Earth? Where did the moon come from, Leo?
I can answer that.
I'd like it.
You'd like so
Yeah.
the leading hypothesis that we have is called the Theia collision hypothesis, which posits that a Mars-sized object struck the Earth roughly about 4 to 4.2 billion years ago and just shattered and remained within the Earth's gravitational field and slowly recoalesced into the moon. The reasons why this is believed is, number one, both the Earth and the moon have very, very similar composition, even though the Earth and Mars, or the Earth and Venus, or the Earth and other meteoroids, somewhat similar, but not nearly to the level that the Earth and the moon are. Also, the Earth is tilted 23.4 degrees north on its axis. It rotates and it wobbles about its axis or precesses. The direction of its precession is in the same direction of its orbit, which is in the same direction that the moon, or the same direction of its rotation, which is also the same direction that the moon orbits it, and the moon is also moving away. All of this together seems to indicate pretty strongly that a massive object struck the Earth, tilted it, rotated it, precessed it, it recoalesced, became the moon, and is now slowly, very, very slowly moving away from the Earth.
Well, what you're referring to is called the ejection theory. Something struck the Earth and ejected the moon out into space, into this orbit.
No, nothing left. Well, some matter would have probably left the Earth, but not a moon-sized piece.
You understand the moon is nearly perfectly spherical. I mean, it's real close to exactly round. Huh?
So is the sun. So is Jupiter.
So does the moon have enough gravity to pull itself into a sphere like that?
Yes.
It does. Okay.
Yes.
Well, that's another long, interesting. I think the capture theory and the ejection theory that he's referring to here have long been disproven mathematically.
I'm referring to neither of those. In fact, I specifically outlined what I'm referring to is called the Theia collision hypothesis.
Okay, let's do this. Kent, take the last word because it was your question, then we'll move on. No worries. Great discussion on these questions, gentlemen. Kent, go ahead. Last word.
Giving it a long, fancy name, a new name for the same old theory that something hit the Earth and ejected it out. That's called the ejection theory, whatever name you want to give it. Anyway, I think it's been proven wrong mathematically a long time ago. And it does put a time limit. So the question was about the inverse square law. And the fact is the Earth-Moon system cannot be billions of years old. So you have to have a way to answer, how did it get here? And I got a simple answer. God created it. I trust God to do it and to leave a book behind to tell me that he did it. He said he made the moon in day 3 or day 4 with the rest of the sun, moon, and stars. He made the planets later. He made the stars after he made the Earth, according to the Bible. So I've chosen to believe that. So far, I don't see a problem with it.
Thank you guys for Great back and forth there. People are loving it. We're at 360 people right now in the chat for this epic debate. So that being said, next question comes in from Daniel Mira. I appreciate the question, Daniel. This one's now for you, Leo. He asks, please ask Leo, how does the Big Bang model explain the existence of information in the universe? And then he says DNA, for example. Oh, Leo, you're on mute.
I don't know what DNA has to do with cosmology. Information is just that which informs. So information is a physical thing. It's not like an immaterial thing. An atom is information. The rate of its orbit around the nucleus of an atom is, or like an electron, has information. Its spin state is information. Its magnetic moment is information. Its electric dipole moment is information. All of these things are information. If there were no physical reality, there would be nothing that which you could get information from. There would be nothing to inform you. You wouldn't have information. And I can cite peer-reviewed academic literature from some of the fathers of communication theory and information theory, stating that, like Rolf Landauer and Claude Shannon, saying that information is understood as being physical.
Thank you, Leo. And Kent, if you had a response, go ahead.
Well, this is a whole new debate, but I think the complexity of information, the complexity of the DNA molecule, for instance, it defies a random. It has to be a designer. If I told you this book had no designer, all the ink on these pages just came there by chance. No, this is more than just ink on paper. This is carrying information. And the DNA molecule is incredibly complex, way more complex than the space shuttle or the whole United States internet system. Just one DNA molecule. And you got a bunch of these in every cell in your body and 100 trillion cells in your body. I think the existence of the phenomenally complex information in a single cell is mind-boggling and God deserves the glory for that, not something striking the earth.
Thank you, Kent. Leo, to be fair, question was originally for you. Go ahead. You can have the last word.
I would just like to end on this question with just this very, very quick, very short quote from a paper published in the Royal Society Publishing. I cannot remember the names of the authors off the top of my head. They say, quote, "Nonetheless, we expect that the study conveys an obvious but clarifying thought, namely that information is nothing but physical, to imply that the thermodynamic rather than the mathematical theory accounts for communication," end quote. And if anybody is interested, I can throw that link to SFT, and I'm sure he would enjoy either putting it in the live chat or in the description of the video.
Definitely. Okay, so thank you for that. Just skimming through these questions. Got to make sure I get the super chats. Here is a super chat from Bubblegum Gun. Thank you so much for the super chat. He says, a question for Leo. Leo, is the universe a perpetual energy machine?
I don't really know what context he's asking. The universe isn't a machine of any sort. I mean, if he's asking, could energy just like continue to do work endlessly in the universe? No, because of the first and second laws of thermodynamics.
Oh,
Right, I appreciate that. We can, unless Kent, you had something you wanted to add.
Well, no, I agree. It had to have a beginning. Had to have a beginning. Whatever it was, there was a beginning. I think the perpetual universe is not perpetual motion. It is losing energy, being dissipated. First and second laws had to be a beginning, which is what my book says in the very first verse.
Okay, let's move right on to, well, it was your question, Leo. You want a quick final word? Or
yeah, just something really quick. The question of whether there's a beginning to the universe, number one, is an open question, and number two, depends on what the person that's saying it means by the term beginning.
Okay, next question, again for you, Leo. He says, using the law of centrifugal force, why do galaxies spin in opposite directions?
Because that's the way they formed.
Oh,
I'm sorry, there's more? Yeah, please.
Yeah, I'm just going to read this word for it because he actually tagged you both. So maybe this is just a question for both. He just says, using the law of centrifugal force at Leo, why do galaxies spin in opposite directions? At Kent, how does biblical creation explain this? So kind of a question for both of you. Leo, if you want to start, then we can let Kent answer, and then.
The same reason why on a Monday the wind might be blowing out of the northwest, and then on Wednesday it might be blowing out of the southeast. That's just the way that it is. There's nothing that indicates that we should expect all galaxies rotate in exactly the same direction. So I guess it would just be, why should we think that galaxies should rotate in the same direction?
Thank you, Leo. Kent, go ahead. The floor is yours.
Well, this is a very complex problem, I think, for the evolutionists to explain. The retrograde motion of several of our planets. Venus and Uranus spin backwards. Several planets have moons going both directions at the same time. Why do any planets spin at all from a Big Bang? From a Big Bang, you've got linear motion going out. Particles are going out linear, in a linear straight line. How did they collect and begin to spin? Where did spin come from? Anyway,
conservation of angular momentum.
Well, what moment? There is no angular momentum. If they're all going straight line from your Big Bang, none of them should be spinning.
Well, they spin as things accrete as a result of gravity.
Leo, every atom is spinning.
No, atoms don't spin.
The electrons around the atoms are spinning.
No, they're not. They have a spin. There is nothing there physically rotating. That's just not. You can't look at elementary particles, Kent, as if they're classical objects. That's just, again, this gets deep into physics, and we're just
real deep. Yeah.
We don't need to go there.
Okay, Kent, you could have a quick final word, and then we'll move on to the next question.
I think the retrograde motion of planets and moons and galaxies is a powerful proof against the Big Bang. I think God did it just to be able to laugh at these folks on Judgment Day. Aha.
Well, I appreciate the answers there, Kent and Leo. This one comes in from Ra. This is a super chat, $10 super chat. I appreciate. Questions for you, Kent. She says, are you aware of the Gaia spacecraft, how it can measure stellar parallax of stars up to and beyond 6,500 light years away, because the 6 centimeters that separate the human eyes are expanded to some 300 million kilometers? Kent, I just read that word for word. So go ahead.
I'd have to see the drawings on that. I taught trig for a long time. I think I could understand it pretty well. And I think I show in my seminar clearly that most scientists are admitting you cannot measure beyond about 300 light years. And I think that's a stretch. So this person is saying now how can a new spacecraft, which has to be someplace in our orbit above our atmosphere, still not going to increase anything? You might get rid of some of the atmospheric distortion because you're no longer going through the air, but you still have the same parallax problem of measuring distance. So I'm going to say I don't believe the 65,000. And even then, if they can measure 65,000 light years, let's assume they can, that's not billions. And a light year is a distance. It has nothing to do with the age. Again, if the heavens are being stretched out like the Bible says, they could have been made 5 seconds ago and be 65,000 light years away. So it doesn't solve any problem at all for the Big Bang folks.
Thank you, Kent, and thanks for the super chat. Leo, if you wanted a response, go ahead.
Yeah, they're called light years because time plays a factor. And that's kind of like how we measure things like speed, which is in physics or in mathematics the first derivative of position with respect to time. So if we know what something is in light years, then we know how long it took light to get here. So if something's 13 billion light years away, that light has been traveling to us for 13 billion years.
Thank you, Leo. Kent, go ahead. Final word.
Well, that's what I covered much earlier. That is absolutely simply wrong, Leo. You don't understand. A light year is a distance. It is not a time. It's
how do we measure
light
distance?
Can travel. If light traveled at twice the speed, would a light year still be the same distance? We said light can be slowed up or speeded down. A light year is simply a distance. It is not a time. It is not a year. So it's a long ruler to measure stuff with. That's all it is.
How do you measure distance, Kent? How would you measure the distance that something has traveled?
Well, you measure distance in miles, or if you want to do it in kilometers in the metric system. We have measured distance all the time. I used it today quite a bit to measure the distance between the boards we're nailing together. So,
so how do we measure distance with light?
Well, using the light year is simply having a longer ruler. Instead of saying it's 400 trillion miles. I'm sorry, what?
It's distance over time, correct? That's why it's a light year. And a year is a measure of time. I understand,
but you're not getting it, Leo. A light year is a distance. It is not. It's not a year.
And how do we measure that distance?
That's my whole point. They can't measure those distances beyond
time of travel.
You don't know the time of travel.
Yes, we do.
You
It's
do?
1 light year, which is how far light travels in a given period of time. Yes,
And if
time
light could
plays
go
a factor
faster,
here.
yeah, if light could go faster, or we're back to the same argument. We already covered all this, but watch my video number 7. I'll send you one for free if you'd like. Send me your address.
Okay, we'll give Kent the last word on there since it was his question. This one's kind of off topic, but you guys kind of have gone back and forth on the age issue a bit, so we'll get it in there. Question comes in from Sandra Jones. I appreciate the question, Sandra. Let me see here. It says, question for Leo. If the world is millions of years old, how do you explain petrified trees running through different layers of rock? Now that I'm reading through that, she probably refers more so to the Earth itself. But if you want to respond, go ahead, Leo.
Yeah, that's just quite frankly, it's not related to the topic of the discussion of tonight's debate.
All right, guys, let's.
Well, I'd like one comment.
Sure. Sure.
One of the absolute key points that atheists and evolutionists use to support their religion is Big Bang, which is the topic for tonight, and also that the layers of the Earth are different ages. And they've got names for them: Cenozoic, Mesozoic, Paleozoic, Archaeozoic, and Jurassic, Triassic, Mississippian, Devonian, Silurian. It's all baloney. That geologic column they teach does not exist any place on the planet except in the textbook. I taught Earth Science 15 years. There is no geologic column. And he's right. Rob, whoever asked the question. Trees are found standing up, connecting all these layers. Petrified trees. Okay? The layers aren't different ages. If they say the top layer is younger, I say, really, where did it come from? Outer space? Every speck of dirt on the planet is the same age. Whether it's billions or thousands, it doesn't matter. For the sake of the argument, every speck of dirt is the same age. It just gets recycled. So the whole geologic column is a gigantic hoax. It doesn't exist anywhere except in the textbook. And most of them will admit it. It's purely made up. So the polystrata trees are polystrata of animals. They found a whale going through many different layers of diatomaceous earth in Lompoc, California. So the layers are not different ages. But the starlight and Leo's problem here, teaching that the universe is billions of years old because of Big Bang and starlight, or using the starlight as an example to prove the Big Bang, is just like using the layers to prove the age of the Earth. It does tie together for the age of the Earth. So polystrata trees, Tennessee's got a bunch of them. They're proof the layers are not different ages, which would happen in a flood. In a big giant flood, 1 year, tide going up and down, in and out, 880 times while Noah's in the ark, would make thousands of layers in 1 year. Go ahead.
Thank you, Kent. Leo, to be fair, the question was aimed at you, so you can have the final word there if you want or something.
Yeah,
like
it's just on the last point that Kent made. Tide goes in, tide goes out. That's just the way. It's just the way it goes.
That's the way it is.
All right. Well, this has been awesome so far. We've got 2 more super chats. They both come in from somebody named Pseudonym, and one's for Kent, one's for Leo. So let's get this one in here. I appreciate the super chat, Pseudonym. He asks, Kent, do solar panels violate the second law of thermodynamics?
No, nothing violates the second law of thermodynamics. It's a law. They're taking the sun's energy. Let's say let's give it a number and say the sun is producing 10 units of energy. The solar panel can capture maybe 1/10 of that amount and change it into electricity. All along the way, as it changes from solar energy to electrical energy and it's transmitted through the wires, the size of your copper wire everything's going to diminish. I mean, you might get a more efficient system, maybe up to 20% efficient or 30%, but you're still not violating the second law at all. Everything is degenerating. So the sun has to use up a lot of its energy to produce a little bit of energy for your solar panel.
All right, thank you, Kent. Leo, if you wanted a quick if you wanted to add
Yeah,
something.
Kent's just referring to global entropy, which is always decreasing. Local entropy, like say on the Earth, is not decreasing or increasing. My bad.
Go ahead, Kent. Last word.
Entropy increases everywhere that I've ever seen. You have to add a lot more energy, and even then it doesn't last. You organize your car and it gets disorganized again, and you have to adding gas to your gas tank. And I think the only way to overcome entropy is to keep adding more and more energy, which means you're taking it from somewhere else, like from your body, to clean the floor in your kitchen. Now you used up your energy to organize the house, which is going to get disorganized again. But I have to disagree. I think entropy increases everywhere we look.
Thank you, Kent. Thank you, Leo. So this next super chat from Pseudonym is directed at you, Leo. And the question is, I'll read it word for word. He says, don't you lose by default when you say the universe might have existed without tense when you're supporting Big Bang Cosmology ? Go ahead, Leo. What are your thoughts?
No, all to say that the universe or that time is tenseless is simply to state that what we recognize as the tenses of time, past, present, and future, and the distinction between them is not an objective feature of reality. It is merely a subjective feature of our conscious experience of time, and this has been indicated by both special relativity and general relativity, as well as numerous aspects of quantum field theory. Time, the universe, is tenseless.
Thank you, Leo. Thanks for the super chat, Ken, if you wanted to add anything.
So there is no past tense or future tense, Leo?
As an objective feature of reality, no.
So are you here today, right now, or are you here right now, tomorrow?
I'm here right now.
But there's no tense.
Of course.
Well, right now would involve a tense.
Well, right now
Present.
is based off of our conscious experience, and we consciously experience tenses. That's the difference between them being an abstract convention that we use and them existing objectively in reality independent of that. The former would be true, the latter would not.
I also want to jar this tense in my science center too, but that's enough. Go ahead.
All right, this is great. So correct me if I'm wrong, Leo. There is a super chat here again from Mitchell. So I want to make sure I get through the super chats. If I already asked this one closer to the beginning, I apologize. So his question for you is, do light particles travel in a vacuum of space without a medium?
Technically, yes. But in some other vague sense, no. So in the sense of yes, electromagnetic radiation, when it's propagating at sea through the vacuum of space, is not those photons are not interacting with anything. They're what's called free streaming through the vacuum of space. However, what photons are propagating disturbances or perturbations in the electromagnetic field. So if you wanted to call the electromagnetic field the medium through which the perturbations propagate, you could, but that just comes down to semantics at that point.
Think you, Leo. Dr. Hovind, go ahead.
I think this is an unanswered question for generations. Okay, but I don't know anybody's had an answer to that one. My dad was an electrical engineer. He never had an answer for it. So how does light go through a vacuum? To say it perturbs the magnetic field and stuff. Maybe it is magnetic propagation. Doesn't matter to me. I use it all the time without even caring. I just flip the switch and it comes on. I'm happy.
Thanks, Kent. Leo, final word real quick.
Yeah, it's what could be called a normal oscillatory propagation or a normal sine propagation in like mathematics terms. The electric and magnetic fields are perpendicular or normal to one another, and they oscillate. So they would just oscillate back and forth like that through the electromagnetic field, and that is what we call electromagnetic radiation. And just lastly, electrical engineers aren't physicists. We shouldn't expect them to understand the basics of, say, classical electromagnetism, special relativity, and the quantum field theory of the electrodynamics and things of that nature. If you want to know answers to those kinds of questions, consult a physicist, not an electrical engineer.
Okay, and we're going to end with this last one here from Iron Matt. I apologize to anybody in the chat. We've had a massive chat today, and we are coming at the 2-hour mark, so we got to end it somewhere. So I apologize if we didn't get to your question or super chat, but I do want to say thank you for sending in your questions and super chats. This debate really has lived up to the hype, gentlemen, Kent and Leo. So here we go. Iron Matt asks, Leo, so how is the universe a 4-dimensional something that can't be measured, and it's not really a thing you can measure? How can it both be measured and unmeasurable?
I guess I don't know what the person asking the question means by measured. We've measured space-time. We do it all the time when we use, general relativistic equations. Like, what do you think the curvature is in? the geometry of space-time. We've measured it. We measured it with special relativity, which is how we know that it's four-dimensional. Objects affect not just space, but time. That's also been measured. It's called gravitational time dilation. So it is a four-dimensional manifold. Space and time are interconnected. We have measured them. We know it's real. We know it's physical. We know it's there. We know it's dynamic, and we know it's expanding. What it is fundamentally, if it even is a fundamental thing itself, we don't yet know, because humans don't know everything and shouldn't be expected to know everything. We go back 400 years, they didn't know what the hell magnets were or how they worked. That didn't make it magic. We now know how magnets work, and in probably 40 or 50 years, we will know what space-time is and whether or not it is itself emergent or fundamental. Not being able to answer certain questions doesn't mean other questions related to those either aren't answered, haven't been answered, or can't be answered.
Okay, thank you so much. Dr. Hovind, go ahead.
No, nothing to add to that. Go ahead.
Okay, so I want to thank you guys again for an epic debate. This was awesome. Leo and Kent. Before we shut it down, let's have some final words, final thoughts from the debaters. Thank you so much again for giving us your time for this debate. Extremely generous. So why don't we start with Kent? Kent, final words, final thoughts before we shut it down for the night.
Well, it's been estimated as of 20 years ago that every person on Earth could own 11 trillion stars. 70 sextillion stars was the estimate, probably more now. If they get bigger telescopes, they're going to probably find some more. You want all that to fit in a dot. I just find it hard that anybody could believe such a thing, but that's your choice. I believe the Bible says the heavens declare the glory of God. God ought to get the glory for the amazing heavens that he made. I don't have a problem with that. And the psalmist said, when I consider the heavens, that's when you say, what is man that thou art mindful of him? There are some people who want to elevate man to some form of godhood. That's what Satan said to Eve. You eat off that tree, honey, you get to be like God. She fell for it. And I think the evolution theory today has fallen for the same lie. We got here from a Big Bang, and we came here from no reason, and we're God. We're king of the universe. And I think that's going to be a sad position to have to think about for the next 400 trillion years if you go to the hell you mentioned a minute ago. I hope you don't, Leo. I'd like to see you come to heaven. Thank you.
Thank you for those final words, final thoughts, Kent, and thanks for agreeing to this debate. Leo, before I hand it over to you, though, before I forget, I want to let everybody know there are 2 after shows that I know of. We've got one on Logical, Plausible, Probables channel. John, thanks for the super chat. Says after show starts right after this debate. Link in chat. And Leo, correct me if I'm wrong. There's also an after show over on Amy Newman's channel.
That is correct. I think hers is starting somewhere probably around 9:15 or 9:30. I would suspect.
All right, I appreciate that. So that being said, Leo, thanks for doing this debate. Final thoughts, final words. Go ahead.
Yeah, there was one point that we didn't really touch on in a debate. It's not really entirely related to the subject, but I figured I'd mention it. Kent had some slides going up about how we don't even know that stars can form or how. Yes, we do. We've watched them form. If you don't believe me, look up the star W75NB-VLA2, a protostar which is about 4,200 light years from Earth. We have watched it for a very long time, and we've been watching it since 1996. And we have watched and observed numerous stages in its development, all a result of general relativity and gravity and what is called accretion. You could just Google accretion. It's on Wikipedia. I mean, if it's on Wikipedia, believe me, it's something that's not going to be hard to find. These are things that as astrophysicists and cosmologists have understood for decades.
All right. Well, thanks for those final words, Kent and Leo. Thanks for giving us a debate to remember. Thanks to everybody in the chat for your support, your super stickers, super chats, and questions. That being said, we will see you over at the after shows. God bless. Standing for Truth is out.